So like I said, it's going to be important that we remember here that secant of x is 1 over the cosine of x, and that cosecant of x is 1 over the sine of x, like that. Okay, so let's just pick at random here, and we'll just do, let's graph secant of x. Okay, we'll graph that. So before we go to graph that, though, what we'll do is graph cosine of x. Okay, so let's take a look, and then we'll kind of like logic or reason our way through what secant will look like. Okay. Okay, so since it's just plain old cosine that we're going to graph first, right? Plain old cosine. That means that our period is going to be from 0 to 2 pi. And I'm going to do 2 full periods here. So I'll do 0 to 2 pi and then out to 4 pi. Okay. And then, of course, for each one of those 2 periods, right, 0 to 2 pi to 4 pi, I'll go ahead and find the halfway point and then the quarter points as well. And then same thing here for the 2 pi to 4 pi. And then I'm going to use a pencil to graph cosine so I can erase away the cosine. Because again, we're going to use cosine to help us graph secant, but our ultimate goal is to graph secant. I'm going to use the cosine to help us. And so I'll show you again here. So again, just plug in 0. Cosine of 0 is 1. Cosine pi over 2 is 0. Cosine pi is -1, 0, 1, 0, -1, 0, 1, like that. Okay? And so there's... Actually, I'll just go ahead and just connect it lightly here. There's our graph of cosine. Okay, no transformations, nothing crazy there. Okay. And the course continues on. Okay, so now let's think about what kind of points we're going to have here. So again, when it comes to graphing cosine, we kind of focus on the highs, the lows, and the zeros, right? So the height, the maximums, right? Relative maximums, relative minimums, and then also the zeros too, okay? And that's basically what we're going to need for secant as well. So let's just think about this. Again, as Rose said, let's think about secant as being just the reciprocal of cosine. So cosine, when I plugged in 0, gave me 1. That means secant, when I plug in 0, is going to give me the reciprocal of 1, right? Because secant is 1 over cosine. So if I plug in 0 for cosine here, cosine of 0 is 1. What's the reciprocal of 1, though? 1. So we have a point. At 0, secant, and again, I'll put secant in red there. Okay. At 0, secant will be 1. As well as cosine. So cosine and secant both share those points. Okay. What about pi over 2? Cosine of pi over 2 is 0. What's the reciprocal of 0? It's undefined, okay? How do we indicate something that's undefined in a graph? What do we graph? Not a hole. Well, it could be a hole, I guess, yes. But in this case, it's going to be a vertical asymptote. It's going to be a vertical asymptote. So yes, we're going to have a vertical asymptote show up here. Yes, ooh, indeed. Okay. So then next is at pi, right? Cosine of pi is -1. What's the reciprocal of -1? -1 still, so we'll have a point right there. Okay, and then at 3 pi over 2, what will secant have? Well, what's the reciprocal of 0? It's going to be undefined, so we'll have another vertical asymptote here. Okay, and then at 2 pi we're going to be back at 1, and the reciprocal of 1 is 1. Okay? So basically, everywhere we have a 0, we're going to have a vertical asymptote. So we have these repeating irregularities along with these points as well. Okay. So far that's not a whole lot to go on, right? Because we have like a point and then an asymptote, and then a point and then an asymptote, and then a point, an asymptote, point, asymptote, point. Okay? So it'd be helpful if we get a few more points in here. And so I'll just, help us out with that a little bit, right? So another nice and easy value to find for cosine in here would be cosine of pi over 3, right? Because what is the cosine of pi over 3? Well, cosine of pi over 3, the ratio is 1/2, right? So pi over 3, it's going to be the closest angle here to pi over 2. So we'll say it's like right here maybe. So cosine pi over 3 is like 1/2. So yeah, it's about that, right? What's the reciprocal of 1/2 though? 2. So at about pi over 3, right? Or exactly pi over 3, we should be at 2. So kind of just kind of eyeball it, I guess we'll say. 2-ish, right? And okay, so now that extra point in there kind of helps us a little bit. All right, let's maybe go here to between pi. So between pi over 2 and pi, an easy one for cosine would be cosine of 2 pi over 3. What's cosine of 2 pi over 3? It's in the second quadrant. It's still pi over 3, but now cosine in the second quadrant is what? Positive or negative? Negative, right? So it'd be negative 1/2. Okay? Cosine of negative 1/2 is, cosine of 2 pi over 3 is negative 1/2, so about there. But what's the reciprocal of negative 1/2? It'd be negative 2, so something like down here. Okay? Cosine 2 pi over 3. Okay, so yeah, if you like, I'll put that right there. And that'd be like pi over 3. Okay? I can zoom in some more on that too. Okay? And then let's do one more here between, and you'll get the idea, I think, after this. So between pi and 3 pi over 2, we could use 4 pi over 3. Cosine of 4 pi over 3, it's in the third quadrant. It's going to be negative, so it'll be negative 1/2. Okay? But then, what is the reciprocal of negative 1/2? Well, it's going to be negative 2. Okay? And again, why did I skipped like pi over 6 and pi over 4 and 5 pi over 6 and 3 pi over 4 and stuff like that, because those are got square roots and stuff, so it's harder to kind of like imagine what their reciprocal is going to be. But you can kind of see here what's happening. This is the kind of shape we're going to get. Okay? And then here we got this shape with like another one to still be in there if we were to continue the graph kind of thing. And so as we go, it's going to continue to be the same thing here. Okay, like so. So that when I erase away, everything, okay, what we're left with then is the graph of secant. There it is. Okay, that's it. It's easy. All right. If I go to, so it'll get easier here. I'll show you. Zoom trig 7. So there it is on our graphing calculators. Yes. Let's see here. In fact, I guess I should go from 0 to 4 pi, and that might make it easier to see what we've got. So there it is. Of course, the calculator doesn't draw on the vertical asymptotes, but they are assumed there. Okay. So what's the range for this? What's the range for secant here? So yeah, so negative infinity to negative 1. Oh, and we do get to negative 1, so I should include it there. Range is negative infinity to negative 1. Union, what else? 1 to infinity. Okay, so that's our range here. How interesting. Right? It's like the negative space of the cosine, or negative space of the sine, right? range for sine and cosine, -1 to 1. For secant here, the reciprocal of cosine, it is the exact opposite, right? It's the -1 and then 1 to infinity. The only place that overlaps is at -1 and 1. What about the domain? Is it all real numbers? No, because we're undefined. But the problem is, though, we're undefined infinitely, right? There's like an infinite number of places where we're undefined. So how do we describe the domain for this? We can't say all real numbers. We also have to describe an infinite number of things. So what we're going to do here is say all real numbers except. And then we need to describe these in such a way that we can cover kind of like all of our bases here, right? All of our bases. So there are a couple different ways you can set this up, and there's an infinite number of ways you can write this. But I just like to start with the very first one that we run into, except x equal to pi over 2. Okay, and then to get from pi over 2 to the next one, what's that distance? So from pi over 2 to 3 pi over 2, what's that distance? Pi, right? And then from 3 pi over 2 to 5 pi over 2, what's that distance? Another pi, and then another pi, another pi. So we just keep adding multiples of pi, right? And we'll find more of those asymptotes. Or we can subtract multiples of pi, and we'll keep finding those asymptotes. So we'll put in plus k pi, okay? Comma k is an integer. And yes, it is important that we can describe that domain there, okay? So the idea is we start with one of our asymptotes, and then we just show, okay, and if we add multiples of pi, then we'll find additional asymptotes, okay? Or we can subtract multiples of pi. That's why we say k is an integer, though, because integers, remember, are the positive whole numbers, and then their opposites, the negatives as well there. Okay? Questions on any of that? Okay. So I am not going to show you cosecant because it's the same kind of idea. Okay, I'm not going to show you cosecant because it's the same kind of, exactly, it's just shifted, exactly right. Shifted pi over 2, just like the sine and cosine, how they're related. Okay, what I will do though, let's jump into an example here, okay, so we can try it on our own, okay? Well, not on our own, we'll try another one here together with some transformations and things. Okay, so let's do cosecant of x plus pi over 4. So I'll do a cosecant here, but it's going to be shifted by pi over 4. Okay. Now, of course, for cosecant and secant, we really don't talk about an amplitude here. Okay, we really don't talk about amplitude or anything like that. You could talk about its period, right? You could talk about its period here. So this thing does repeat every 2 pi, right? The original one there. It does repeat every 2 pi. Okay. So let's take a look here at cosecant. So cosecant, right? This is going to be a shift. Which direction? To the left. How much? By pi over 4. Okay, that's all it is. You're just going to shift left pi over 4. That's it. So if you want to here again, we can take that cosecant. We can say, okay, well, normally our cosecant goes from 0 to 2 pi. We'll put that x plus pi over 4 there in between, okay, to kind of account for that shift. Okay, and we'll solve for x by subtracting pi over 4 on both sides. We get negative pi over 4 is less than or equal to x is less than, and then 2 pi minus pi over 4 is going to be 7 pi over 4. So there's our new kind of period there. All right. And again, what I'm going to do here, when I go to graph this, I'm not going to think about graphing cosecant right off the bat. I mean, you can do that if you want to, if you feel like it. But I'm going to graph its reciprocal. What's the reciprocal of cosecant? Sine. So instead, I'm going to think about graphing sine of x plus pi over 4. Okay, I'm going to graph this first. And then I'm going to focus on, fixing it so that it's cosecant. Okay, so we're going to use the sine to help guide us, and then we'll graph out cosecant. Okay, so graph this as if we're graphing sine. Okay. So what's the amplitude going to be for our sine graph? 1. This means the highest we have to go is positive 1. The lowest we have to go is negative 1. Okay. I have to go left to negative pi over 4. And all the way out to 7 pi over 4. So that was, let's see. 1, 2, 3, 4, 5, 6. So I didn't leave myself much space. I'm trying to keep it evenly spaced there, that's all. So I'm trying to use the right kind of like spacing there. So it looks like I'm only going to be able to fit 1 full period in there. I can fix that though. Do 2 full ones here. Let's just focus on our first full period here, and then we can worry about getting another one back. Okay, so we've got our starting point and stopping point, right? Right there, graphed. All right, now we have to find the midpoint, right? So add them up. Negative pi over 4 plus 7 pi over 4 is 6 pi over 4. 6 pi over 4 is the same as 3 pi over 2. Divided by 2, 3 pi over 4. Okay, so the halfway point here, 3 pi over 4. And again, just add them up, simplify, divide by 2. Okay. Now we find the quarter points. Add these up. 2 pi over 4, right? Simplifies to pi over 2, but when you divide by 2, it's pi over 4. So there's our quarter point. And then here, same thing. 3 pi over 4 plus 7 pi over 4 is 10 pi over 4, which simplifies to 5 pi over 2. Divide by 2, that's 5 pi over 4. So you're going to use a pencil here to graph the sine. Questions so far? Questions so far? All good? Okay. So plug in the negative pi over 4. Negative pi over 4 plus pi over 4 is 0. Sine of 0 is 0. Okay. Don't use 0. Okay. Don't use 0 here. Our next kind of point that we indicated here was pi over 4, right? So our quarter point then is pi over 4. Pi over 4 plus pi over 4 is pi over 2. Sine of pi over 2 is 1. And then maybe you get the idea of the pattern from there, right? 0, then negative 1, then 0. Okay. So again, sine would look something like this. Right, if I lightly draw it in there. Okay, like so. And now we're going to graph cosecant. Okay, cosecant is just the reciprocal of sine. So where are our asymptotes going to be for cosecant? Bless you. Bless you again. Where will the asymptotes be? At what points here? In this case? At the zeros. Yeah, at the zeros. Anywhere you have 0, because the reciprocal of 0 is 0, right? So the reciprocal here of negative pi over 4, sorry, when you plug in negative pi over 4, you get sine of 0, which is 0. So cosecant will be an asymptote. So asymptote here. Okay. Asymptote at 3 pi over 4. And asymptote at 7 pi over 4. Okay. At pi over 4, right, sine is going to be 1. What's the reciprocal of 1? It's 1 again, right? So right there. And at 5 pi over 4, negative 1, reciprocal of negative 1 is negative 1. So there's our graph, right? If once you get that bottom point there, you can just kind of, if you want, just sketch it. You don't need to find, more points there. This is what it's going to look like. Okay. Like that. And then we can erase away the sine. If you want to leave the sine curve in there, graph it as like a dotted line or something like that. Don't leave it solid, okay? Don't leave it solid. You really shouldn't do that, right? If you want to if you want to leave the sign in there though, just to help you, if you don't have to erase it every time, just make it like a dotted wave or something like that, just so I can see that.
Just one period.
That's one full period, right?
And
Yep.
each, the width of, I guess, the length of half of it is.
The length of this distance here is still 2 pi. All we did was just shift things left pi before.
There's no b.
Correct. Exactly right. Yep. So it didn't stretch or shrink. We're still a distance of 2 pi from here to here. Okay. It's just got shifted left, and so that made it negative pi over 4 to 7 pi over 4. But yes, if we wanted to continue it on, we could. Okay. So go out. Let's see. I'm going to try and eyeball the right distance there. Something like that. Okay. So if we wanted to, we could go another 2 pi out from this. So that'd be adding 8 pi over 4 to 7 pi over 4, which gives 15 pi over 4. Okay, and then again, you can find the halfway points and the quarter points. Okay, and then go from there about getting the more asymptotes and stuff like that. But it would repeat just like the last one did, up here, kind of thing. Let's see here. So it'd be what? 22 pi over 4 or 11 pi over 2. So 11 pi over 4. Yeah, it's like just count by 2. So 7 pi over 4, 9 pi over 4 there, 11 pi over 4, 13 pi over 4. Okay, and so we'd end up with another asymptote right here, an asymptote right here, and then let's see, it'd be at 1 again. Okay, and then negative 1 right there. If you wanted to extend it there. Okay, question, Jenna?
How did you know which direction the arrows go?
If this is the center, right? If this is the center, then 1 is the highest. If you're at the top, then the arrow's going to go up. If you're at the bottom, the arrow's going to go down. Okay, just think of it almost as like, the reciprocal there. Okay. Yep. The idea is how to know the arrows are going to go up too. I mean, the idea is our y values here are always going to be between 0 and 1. When you take a value that's between 0 and 1 and then do the reciprocal, it gets larger, right? So here, this value right here is very close to 1, so its reciprocal will be close to 1 as well. But then down here, as we get closer and closer to 0, okay, the reciprocal of something that's really, really, close to 0 becomes very, very large, very great, right? 1/1,000,000th, 1 over 1,000,000, if you do the reciprocal, is 1,000,000, right? So it goes all the way up there, kind of thing. But as opposed to something like, I don't know, 9/10, 9/10, which is close to 1, becomes just 10/9, which is just a little bit more than 1, kind of thing, right? So the fractions there. The closer you are to 1, the less it goes up by. The closer you are to 0, the way more, reciprocal goes way up. And then opposed to these, which are just negative, but the same kind of idea. Okay. Any other questions so far? We do one more here with some more transformations, and then I'll have you guys try one on your own. Okay. All right, let's do one more here. Let's do this one. Okay. And then I'll have you guys try one. 3 secant pi x plus 2. Okay. 3 secant pi x 2, or again, we're going to think of this as 3. What's reciprocal of secant? Cosine. Okay, so think about this as graphing 3 cosine pi x plus 2, and then we'll just convert it to secant. Okay? So again, we'll take what's in the parentheses there, that pi x, put it between 0 and 2 pi to transform our normal period of 0 and 2 pi for cosine, and also the normal period for secant. Put it between the 0 and 2 pi, solve for x, so we'll divide both sides by pi. And so we end up with 0 less or equal to x less than 2. 0 to 2. What's our amplitude for the cosine going to be here? 3, but it's also going to be shifted what direction? Up 2, okay? So what's the highest y value we're going to have here? 5, right? Because we're going to have our center is shifted up 2, but then we're going to go 3 up from that center. So that plus 2 shifts our center up 2. And then negative 1 will be the lowest because we'll go 3 up to the 2, so 5, and 3 down to the 2, so negative 1. Okay? So when you go to, set up your axes here, you're going to want to make sure that you include a little bit more on the positive part of the y-axis than the negative. Okay? Like so. So let's see. I'll say there's negative 1, 1, 2, 3, 4. Oh crap! I didn't leave myself much space. 5. And since our period here is from 0 to 2, well, that's kind of interesting. We kind of eliminate the pi from our x-axis there. So it's just 0 to 2, and then we'll do one more full period, so we'll go out to 4. And again, find the halfway points and the quarter points. So halfway between 0 and 2 is 1. Halfway between 0 and 1 is 1 half. Halfway between 1 and 2 is 3 halves. Okay. Halfway between 2 and 4 is 3. And then 5 halves, and then 7 halves. Okay. So no, the pi has disappeared here because with that pi x there, when we divide both sides by pi, okay, the distance, the length of our period now starts at 0 and goes to 2. It's just a distance of 2. That's it, a nice whole number. Okay, but the pi's are still there, right? When we plug in the 1/2, it'll be 1/2 times pi. Right? When you plug in 0, it'll be 0 times pi, and so on and so forth. So pi will show back up before we have to evaluate it. Stuff. All right, so again, let's do our cosine. Oh, I forgot one more thing. I'm going to use my pencil for this, though. So our new center is shifted up 2. So I'm going to go ahead and draw that kind of dotted line to help guide us there. That new center. Okay. Again, that's from that plus 2. And obviously you can just plug in these points, right? So plug in 0. 0 times pi is 0. Cosine of 0 is 1. 1 times 3 is 3, plus 2 is 5. So 0, 5. Okay, plug in 1/2. Pi times 1/2 is pi over 2. Cosine pi over 2, 0 times 3 is 0, plus 2 is 2. Okay, and then plug in 1. 1 times pi is pi. Cosine pi is negative 1. Times 3 is negative 3, plus 2 is negative 1. And then so on and so forth, right? Back to the axis. Back to the top. Back to the axis. Back to the bottom axis. And back to the top there. Okay, and so again, this would be our cosine graph there. So there's what the graph of cosine pi x, 3 cosine pi x plus 2 would look like, right? But we want to graph this secant right here. Secant. Is this all today?
Check. First check the homework, and then the packet for today and tomorrow.
Okay. What about this, the sequences worksheet 1? What's that? Homework. So classwork, homework. Gotcha. Okay.
Quick check.
Quick check. Gotcha. Thank you. Okay. So, question, Jenny, yes.
So how are you evaluating this so quickly? When you do the 3 cosine times pi x.
So I just plug it in, 0, right? Plug in 0. 0 times pi, right? 0. Cosine of 0 then. And that's where we go back to our unit circle stuff. But all these points when we do what we're doing here, okay? 0, 1/2, 1, 3 halves, and 2. When you plug them back in here, you're going to end up at those like four kind of like positions that we have on the unit circle there, where it's either going to be, you know, for cosine it'll be 1 and then 0 this way, and then -1 and then 0. Or, and the same thing for the sine. It's going to be, you know, same thing, but just it's sine, you know, 0, 1, 0, -1 kind of thing. And so that's the purpose of finding these particular points, is it gives us those nice and easy ones to evaluate. And then you just multiply that answer by 3 and then add 2 to it in your head, mathematically, you know, arithmetic kind of thing. So again, plugging in 0, pi times 0 is 0, cosine of 0 is 1, times 3, 3, and then add 2, 5. And so at 0, we end up with 5 eventually, kind of thing. Does that kind of make some sense? Okay. Also, though, Jenna, if you want, you don't need to do that arithmetic. We can use the idea here that cosine, okay, the graph of cosine has a typical kind of like look to it, okay? For cosine of x, it, for the way we set things up here, it starts off the axis, off the center, goes down and hits the 0, then bottoms out, then hits the 0, and then ends back up at the top like that, okay? Looking like almost like a C, right? Cosine. If you then want to remember for sine, sine starts at the 0, goes up to 1, goes back to 0, goes down to -1, 0, and like that. Okay? Looks like an S. So you can use that instead if you want to. Just remember the shape and just know, okay, you know, since I've shifted everything up 2 and this is cosine, okay, cosine's going to start up 3, then to 0, then down 3, then to 0, up 3, down, you know, so on and so forth. So you can use that too if you want to, rather than having to just evaluate things. Just remember the shape. Does that help? Okay. So we're not quite done yet, though. So here's where it gets a little bit funky, all right, but it still kind of follows the same kind of idea, okay? At the peak, you're going to have that same number, and at the valleys or the troughs, you're going to have those same numbers. So these are all points for secant, okay? The asymptotes are now going to occur here, okay? These are now the asymptotes. But Mr. Widd, the reciprocal of 2 is 1/2. It's not undefined. Okay? And you're right, but think about this. If I plug in 1/2, okay, if I plug in 1/2 to cosine, it's pi times 1/2, so pi halves. Cosine of pi over 2 is what? 0. When I plug in 1/2 here, I'm doing pi times 1/2, pi over 2. Secant of pi over 2 is the reciprocal of 0, undefined. It doesn't matter that I'm going to multiply by 3 and add 2 later. Undefined is undefined, right? So the 1/2 makes cosine 0, and then we multiply by 3, and then we add 2. But once cosine 0, that means secant's going to be undefined there. Times 3 plus 2, it doesn't matter. It's still undefined, okay? Same thing up here with like the 5, right? If I plug in 0 for cosine, pi times 0 is 0. Cosine of 0 is 1. Well, if I plug in 0 here, it'll be secant of 0, which will still be 1, because the reciprocal of 1 is 1. So times 3 plus 2 gives us the 5, okay? So it still ends up with the heights, the highest highs, right? The relative maximums there stay, you know, points on our secant graph, and then the minimums, the relative minimums there, stay points as well. And so it basically just shifts like this. Okay. So we can just, again, use those heights and the minimums to create the remaining part of the graph there. Like so. Okay, and if you want, you can erase it, or since I did a dotted line there, I'm just going to leave it. But that's the idea. Questions on any of that? So what I think I might do here then is just give you a chance to get started on the assignment, okay, and you guys can practice some of these on your own, okay. So, that being said here, let me give you the assignment. All right, and it's going to be out of the book, page 337, numbers 15, 21, and then 27 to 33 odd. Okay. But ignore any cotangent graphs for now. Okay, if you see cotangent stuff show up, ignore that for now. Okay, if you didn't get a chance to do the homework from from Wednesday, right? That homework we just went over earlier. I'll put those up too. Page 326, numbers 29, 33, 49, 57, 73, and then 94. Okay, that's what we did. That was homework from yesterday, or from last class day.
So
No.
I was thinking.
Finish up your test.
I don't know. I think I'm done with it.
You're done with the test?
I don't know. I think yeah, 'cause I don't. I can't keep looking at skills for the test because I gotta spend